welcome back to my channel. So today we are going to be discussing the gross anatomy of the lungs. So as usual, I'm going to give you outlines on how to answer questions on the gross anatomy of the lungs. So the first, we are going to introduce the lungs. We're going to talk about the features, that is the apex, the base, the borders and the surfaces of the lungs. Then from there we'll talk about the features and the lobes, the surface markings, the roots of the lungs, where we have the contents, the arrangement of structures and the relations of the lungs. Then we'll talk about the vasculatures, that's their nerve supply, their lymph drainage, the arterial supply and all. So we're going to talk about the bronchial tree that enters into the lungs, right? And then we're going to talk about the bronchopulmonary segment and the clinical correlates. So stay tuned to the end of this class. So this is a typical representation of the lungs. So the lungs is a pair of respiratory organ that is situated in the what? Thoracic cavity. So we have the right lungs and we have the left lungs. So this right and the left lungs are being separated by a space, or what we call the mediastinum. So this is the mediastinum, which is the septum that separates the right lung from the left lung in the thoracic cavity. So please, if you've not watched my video on the mediastinum, please do so. I'll leave the link in the description box below. So the lungs is spongy in texture, okay? But in the young, the lungs is brown or gray in color. So it's brown or gray in color. Now the right lungs is about 700 grams, so it weighs about 700 grams, and it's been said that the right lungs is always 50 to 100 grams heavier than the left lungs, which simply means that if the right lung weighs about 700 grams, that means the left lung will be weighing about 500 to 600 grams. Okay, so this is like 500 to 600 grams because it's about 50 to 100 grams heavier than the left lungs. Now, each of these lungs contains what we call the bronchopulmonary segment. So stay tuned to the end of this class for you to understand the bronchopulmonary segment, because we are going to talk about that. Now, let's talk about the features of the lungs, okay? Now, we are having a blunt apex that is being covered by a suprapleural membrane. Here we are having the trachea, okay? Then from the apex, we are having the base. So this is the base of the lungs, and this base is concave or semilunar in shape. Now the lungs has three borders. It has the inferior border. So this inferior border, the major work of this inferior border is to separate the base of the lungs from the surfaces. That is, it's going to be separating the base of the lung from the costal surface and from the medial surface. So the next one we are having is the posterior border. So this is the posterior border, and finally we are having the anterior border. So this is the anterior border. Now, the major difference between the left lungs or the right lungs and the left lung is that the left lung presents an impression, okay, which is called the cardiac notch. So here we are having the cardiac notch, but the right lungs do not present that. So the right lung is more of like a straight, unlike the left lungs that present the cardiac notch. Now, below this cardiac notch, we have a tongue-shaped projection. It is only seen at the left lung. Below this cardiac notch, you have a tongue-shaped projection called the lingula, just at the level of the left lung below the cardiac notch. You understand? Then the next one we are going to talk about are the surfaces of the lung. So we have two surfaces, the medial surface and the costal surface. So this is the costal surface, and this is the medial surface. So this medial surface is divided into two parts. We have the mediastinal part and the vertebral part. So this is the mediastinal part and the vertebral parts. So this is for the introduction and an overview of the features of the lungs. So let's take it all over again. The lungs consist of a blunt shape or a blunt apex, okay, that's been covered by a suprapleural membrane. It consists of the base that is semilunar or concave in shape, has three borders. The inferior border, the posterior border is thick, while the anterior border is thin, okay? So the anterior border is thinner while the posterior border is more thick. Then it has the inferior border that separates this base from the surfaces of the lung. So it's going to be separating the base of the lung from the costal surface and from the medial surface, okay? Now it has two surfaces, which is the costal surface and the medial surface. Some people call it the mediastinal surface, but the medial surface is actually divided into two parts, which is the mediastinal part and the vertebral part. So in the course of this class, I'll be putting up a diagram to explain the mediastinal part and the vertebral part of the medial surface of the lungs, okay? So that's all for this. Now let's go into the features of the lungs proper. So let's talk about the fissures and the lobes of the lungs. So this is the fissures and the lobes of the lungs. Remember that this is the trachea, and we are having the apex, which we defined during when we are talking about the features. So this is the right lungs, and this is the left lung. So the right lung has three lobes that is separated by two fissures, while the left lung has just two lobes and is separated by just one fissure. So the left lung has the superior lobe or the upper lobe, and the inferior lobe or the lower lobe. So it's separated by the oblique fissure. Remember that this is the cardiac notch, as we've labeled when we are talking about the features, and this is the tongue-shaped lingula that is below the cardiac notch at the level of that, at the left side of the lungs. So this is the upper lobe or the superior lobe for the right lungs, upper and superior lobe. Now this is the middle lobe. And finally, we are having the lower or inferior lobe. So here we are having the oblique feature of the right lung, and we are having the horizontal fissure of the right lung as well. Horizontal fissure. So that simply means that the right lung has three lobes, the upper, middle, and the lower lobe, separated by the horizontal fissure and the oblique feature, while the left lung has just two lobes. So there is no middle lobe in the left lung, and there is no horizontal fissure in the left lung. So the left lung just has the superior or the upper lobe and the inferior or the lower lobe and the oblique fissure. Now let's talk about the oblique fissure. So this oblique fissure cuts across the whole thickness of the lungs. Remember that both the right side of the lungs and the left side of the lung has the oblique fissure. So it cuts across the whole thickness of the lung, except at the level of the what? Of the hilum. Now this oblique fissure, as the name implies, runs obliquely downwards and forwards. So it runs obliquely downwards and forward towards the posterior border, okay? At the level of, at about 6 centimeters below the apex of the lungs, and also it goes towards the inferior border at about 5 centimeters from the median plane. So it runs obliquely downwards and forward, goes to the posterior border at about 6 centimeters below the apex of the lungs, and from the posterior border it goes to the inferior border at about 5 centimeters from the median plane. Do you understand? So now let's talk about the horizontal fissure. Now this horizontal fissure tends to separate a wedge-shaped middle lobe from the superior or the upper lobe. So that's what the horizontal fissure does, and it runs horizontally, just as the name implies, at the level of the fourth costal cartilage to meet the oblique fissure at the mid-axillary line. So that's how the horizontal and the oblique fissure runs, okay? So this horizontal fissure runs horizontally, okay? It runs horizontally the level of the fourth costal cartilage to meet this oblique fissure at the mid-axillary line. Do you understand? And it tends to separate the wedge-shaped middle lobe from the upper or the superior lobe. So that's all for the features and the lobes of the lung.
So let's talk about the features of the lungs. Each lungs are conical in shape, as you can see. It has an apex, a base, two surfaces, that is the costal surface and the medial surface. This medial surface is divided into two parts, the mediastinal part and the vertebral part. And finally, the lungs has three borders, the anterior border, the inferior border, and the posterior border that is seen at the back. Now let's talk about the apex. The apex is covered by a suprapleural membrane, okay? It is blunt and lies above the anterior end of the first rib, and then it reaches nearly 2.5 centimeters above the medial one-third of the clavicle. If you've watched my video on the clavicle, you understand that the clavicle has the medial two-third and the lateral one-third. So the apex of the lungs lies 2.5 centimeters above the medial one-third of the clavicle, just medial to the supraclavicular fossa. Now let's discuss the base. The base is semilunar and concave in shape, okay? Now this base rests on the diaphragm, and then it tends to separate the right lungs from the right lobe of the liver, and also it separates the left lung from the left lobe of the liver. It also tends to separate it from the fundus of the stomach and the spleen. That is some of the viscerals that you can find in the abdominal cavity. Now let's go into the borders of the lungs. Remember that I said that the lungs has three borders, okay? Let's talk about the anterior border first. The anterior border, unlike the posterior border, is thin, okay? And it is shorter than the posterior border. Now, there is a difference between the anterior border of the right lung and the anterior border of the left lung. Now, the anterior border of the right lung is straight. What do I mean by straight? It's straight in the sense that it does not present any cardiac notch or any impression. Now let's look at the anterior border on the left side of the lungs. Now this anterior border shows a wide cardiac notch, okay, opposite the fourth and the fifth intercostal spaces, or you can say below the level of the fourth costal cartilage and the lingula. Now let's talk about the posterior border. The posterior border is thick and ill-defined, okay. Now this posterior border is being related to the heads of the ribs and the sympathetic chain. It tends to extend from the level of the seventh cervical spine, that's the seventh cervical spine, as you can see in this diagram, to the 10th thoracic spine. Okay, now the inferior border is the only work of the inferior border is just to separate the base of the lungs from the surfaces of the lungs. So it's going to be separating the base of the lung from the costal surface and also from the medial surface. So going into the surfaces of the lungs has the costal surface and the medial surface. Now this costal surface is large and convex, okay? And it is in contact with the costal pleura and its overlying thoracic wall. While the medial surface, as I said initially, has two parts, the vertebral part or the posterior part and the mediastinal part or the anterior part. Now this vertebral part is related to the vertebral bodies, intervertebral discs, posterior intercostal vessels and the splanchnic nerves. Now the mediastinal part of the lungs is related to the mediastinal septum, okay, and it shows a cardiac impression unlike the vertebral part of the lungs, okay, and a helium and a number of other impressions which differ on the two sides. So talking about the surface markings of the lungs, so we are going to be using this diagram to explain it. Now you're having a red dotted line, a purple dotted line and a blue dotted line. So the purple dotted line is what represents the features of the lungs, and we are going to be using the features of the lungs to explain the surface markings of the lung. So the red dotted line represents the pleura, while the blue dotted line represents the lungs. Now let's talk about the oblique fissure. That's the surface marking of the lungs in accordance to the oblique fissure. Now this can be seen, or the surface marking can be drawn by joining a point 2 centimeters lateral to the third thoracic spine, okay. It can also be joined by a point on the fifth rib in the mid axillary line down to the point on the sixth costal cartilage, okay, 75 cm from the median plane. Or you can put it that the oblique marking is joined by a spine of the third thoracic vertebrae to the sixth rib anteriorly along the medial border of the scapula. Now let's talk about the horizontal fissure. Remember that the horizontal fissure is only present on the right lungs. So this surface marking can be joined by the rib or the costal cartilage, that's the fourth costal cartilage, to the rib or the fifth part of the mid axillary line. So let's talk about the roots of the lungs. The root of the lungs is a short, broad pedicel that connects the medial surface of the lung to the mediastinum. Okay, so this root is formed by structures which either enters or come out of the lungs at the level of the ileum. So the root lies opposite the bodies of the fifth, the sixth, and the seventh thoracic vertebrae. Now, under the roots of the lungs, we are going to be talking about the contents of the roots of the lungs, its arrangements of structures, and the relations as well. So talking about the contents of the lungs, this is a medial view of the right lungs. So its contents include: one, the principal bronchus on the left side of the lungs. The second one is one pulmonary artery, okay? Now we have two pulmonary veins. We have the bronchial arteries, one on the right side and two on the left side of the lungs. Then we also have the bronchial veins, the anterior and posterior pulmonary plexus of nerves, the lymphatics of the lungs, and finally the bronchopulmonary lymph nodes, as you can see. So talking about the arrangement of structures on the lungs, from anterior to posterior, it is similar on both sides. This simply means that both the right and the left lung has the superior pulmonary vein, the pulmonary artery, and the bronchus. But from above downwards, it is different on the both sides of the lungs. This simply means that the arrangements of structures on the right side of the lung include the upper atrial bronchus first, the pulmonary artery, and the inferior pulmonary vein. But on the left side, you're going to be having the pulmonary artery first, the bronchus, and finally the inferior pulmonary vein. So let's talk about the relations of the roots of the lungs. So we have the anterior relation, the posterior relation, superior and inferior relation. So we are going to be talking about the anterior relation first. So the anterior relation of both the right and the left lung, the one that is common on both sides, include: one, the phrenic nerve. So you can see the phrenic nerve on both the right side of the lung and on the left side of the lung. The second one is the pericardiophrenik vessels. And finally, the anterior pulmonary plexus. Then for the right side, the one that is always seen on the right side of the lung, still under the anterior relation, we have the superior vena cava and part of the right atrium. Then for the posterior relation, the one that is common on both sides includes the vagus nerve, as you can see, then the posterior pulmonary plexus. Then the one that is seen on the left side only includes the descending thoracic aorta. And the superior relations on the right side of the lungs include the terminal part of the azygos vein, while on the left side of the lung, it includes the arch of the aorta. Then the inferior relations include just the pulmonary ligaments. So let's talk about the vasculatures of the lungs. So we are starting with the arterial supply. The bronchial arteries supply nutrition to the bronchial tree and to the pulmonary tissues. Now, on the right side, there is just one bronchial artery which arises from the third right posterior intercostal artery, while on the left side, there are two bronchial arteries. Both of them arise from the descending thoracic aorta. The oxygenated blood is brought to the lungs by the two pulmonary arteries, okay? And oxygenated blood is returned to the heart by the four pulmonary veins, which are the right and the left superior pulmonary veins and the left and the right inferior pulmonary veins for both the left and the right lungs, as you can see respectively. So let's talk about the venous drainage of the lungs. So venous blood from the first and the second division of the bronchi is carried by the bronchial veins. So the venous drainage of the lungs is majorly done by the bronchial veins. So the right bronchial veins drains into the azygous vein, while the left bronchial vein will drain into the hemiazygous vein, which is just like a mirror version of the azygous vein. Then the greater part of the venous blood from the lungs is drained by the pulmonary veins. So let's talk about the lymphatic drainage of the lungs. The superficial vessels, okay, that is the superficial lymph vessels, drains into the peripheral living tissues, while the deep lymphatics will drain the bronchial tree, the pulmonary veins, and the connective tissue septa. So the nerve supply of the lungs includes the parasympathetic nerves and the sympathetic nerves. So the parasympathetic nerves are derived from the vagus nerve, while the sympathetic nerve are derived from the second to the fifth sympathetic ganglia. So that's all for the vasculatures, that's the arterial supply, venous drainage, lymphatic drainage, and nerve supply of the lungs. So now let's talk about the bronchial tree. So this is a typical illustration of the bronchial tree. Here, the trachea divides at the level of the lower border of the fourth thoracic vertebrae. Now it divides into two primary principal bronchi, one for each lungs, okay? Now the right primary principal bronchus is about 2.5 centimeters long. Now this right primary principal bronchus is like shorter, wider, and more in line with the trachea than the leftward principal bronchus. Now for the left primary principal bronchus, it is 5 centimeters, unlike the right, which is 2.5 centimeters. So it is longer, narrower, and more oblique than the rightward primary principal bronchus. Another difference of the right and the left primary principal bronchus is that the right makes an angle 25 degrees with the tracheal bifurcation, while the left bronchus makes an angle 45 degrees with the trachea. You can see that the right is 2.5 centimeters long, while the left is 5 centimeters long, okay? That simply means that the left is longer than the right, while the right is wider and it is shorter, but the left is narrower and more oblique. So the right makes an angle of 25 degrees with the tracheal bifurcation, while the left makes an angle 45 degrees with the trachea. So those are the difference between the right primary principal bronchus and the left primary principal bronchus, okay? Now each bronchus enters into the lungs through the ileum, and now they divide into the secondary lobar bronchi, as you can see, one for each lobes of the lungs. Now you remember that the right lung has 3 lobes, while the left lung has 2 lobes. Therefore, the right side of the lung is going to be having 3 lobar bronchi, while the left side of the lung will be having 2 lobar bronchi. Now, each of these lobar bronchus would also divide into tertiary, or you can say the segmental bronchi, one for each bronchopulmonary segment. So we are going to be having, on the right side, we are having 10, and on the left side, we are also having 10 segmental bronchi. So now this segmental bronchi is going to divide repeatedly to form very small branches. The small branches are called the terminal bronchi, okay? Now, there are also smaller branches that are called the respiratory bronchi. Now, those respiratory bronchi aerate a small part of the lungs known as the pulmonary unit. So that's all for the bronchial tree. Now let's talk about the bronchopulmonary segments. The bronchopulmonary segments are well-defined anatomical, functional, and surgical sections of the lungs. These segments are very important because they aid in efficient air distribution, gas exchange, and also helps in isolating infections from the lungs. Now, each of those bronchopulmonary segments are aerated by a tertiary or segmental bronchus. Each segment is pyramidal in shape, as you can see, with its apex directing towards the root of the lungs. Now, each of these segments has the segmental bronchus, the segmental artery, the autonomic nerves, and the lymphatic vessels. Now, let's talk about the bronchopulmonary segment on the right lungs and the bronchopulmonary segment of the left lungs. Now, let's talk about that of the right lungs first. Now, remember that the right lungs consist of three lobes, which are the upper, or you can say the superior lobe, the middle, and finally the lower or the inferior lobe. Now, these bronchopulmonary segments are divided based on their lobes. So, for the upper lobe, we are having three bronchopulmonary segments, which are labeled 1, 2, and 3. So the diagram A shows the costal view of the lungs, that's the costal surface, while B shows the medial surface of the lungs. Now, for the upper lobe, of the bronchopulmonary segment, you are having the apical, the posterior, and the anterior. Now, for the middle lobe, we are having the lateral and the medial bronchopulmonary segment. Now, for the lower lobe, we are having from 6 to 10. Now, you can see that the 7th is not seen on the costal surface. So you can only see the medial basal bronchopulmonary segment on the medial surface of the lungs. So for the 6th, we are having the superior bronchopulmonary segment, the medial basal, the anterior basal, lateral basal, and finally the posterior basal for the right lungs. Now, let's look into the bronchopulmonary segment of the left lung. Now, its division is upper and lower lobes. Remember that the left lung just have only two lobes. Now, in the upper lobe, they have two divisions under the bronchopulmonary segment. We have the upper division of the upper lobe and the lower division of the same upper lobe. So, for the upper division of the upper lobe, it's the same as that of the right lung. So, we are still having the apical, posterior, and the anterior. But for the lower division of the lower lobe, it is now the superior lingular bronchopulmonary segment and the inferior lingular bronchopulmonary segment. Now, going into the lower lobe of the bronchopulmonary segment of the left lungs, we are going to be having the same thing as seen at the right lungs, which is the superior bronchopulmonary segment, the medial basal, which is only seen on the medial surface of the lungs, be it the right or the left lungs, okay? The anterior basal, the lateral basal, and finally the posterior basal.
So we have come to the end of this class. If you stay to the end of this class, thank you for staying to the end of this class. My name is Joy Onyi. I'm a basic medical lecturer and I teach anatomy. I have an educational channel on YouTube where I post most of my videos on anatomy. I also have a Facebook page where I post the notes from the videos I make on YouTube. If this is your first time coming across my channel, you are highly welcome to this beautiful, wonderful, and amazing family. Please do not make it your last by clicking on the subscribe button below so that you could be part of this wonderful and amazing family, and I bet you will not regret it here. Thank you guys. See you all in my next class. Bye.